Ladies and gentlemen, welcome to this joint presentation between ChassisSim and RML Group. Now, why I'm really excited about this presentation, it's not that often you get a meaningful presentation, particularly from the big end of town. What you tend to get is a lot of corporatees and a lot of how good and how special we are. The great thing about both ChassisSim and RML Group is we are two companies that are diametrically opposed to all this. So you're going to be getting a really good presentation. Now, what kicked all this off was was a really interesting job about the cooperation between our two companies. Now, RML Group is a world leader in motorsports research and development. And their track record, particularly in powertrain modeling, speaks for itself. Obviously, ChassisSim's track record in vehicle dynamic modeling also speaks for itself. So what we wanted to do was to grab RML's considerable expertise in powertrain modeling and combine it with the ChassisSim numerical engine. And the way we did that is that we took the ChassisSim driver-in-the-loop DLL, and what we were able to do was to incorporate it into a MATLAB S function. Indeed, this and another job that I will speak about relatively shortly were the two big drivers in the ChassisSim version 3.40 development and the migration from ChassisSim version 3.40 from a 32-bit to a 64-bit architecture. Now, for me, the real ace in the hole here is what RML Group has done by incorporating the ChassisSim driver-in-the-loop DLL into an S function in MATLAB is that a lot of the vehicle dynamics S functions that you see within the MATLAB environment, they're pretty simple linear models. Now, don't get me wrong, for what they do, they're relatively fit for purpose. However, the ability to incorporate this into a full non-linear, fire-breathing, multi-body vehicle simulation package such as ChassisSim is a real game changer. So at this point, let me throw over to Alex Bitker from RML for the rest. But really, as far as I'm concerned, really this is very much an RML story. We at ChassisSim provided the tools, and what you're about to see is something very, very special. So without further ado, Alex, let me hand over to you.
Thanks, Annie. What I will do is I will take you through a company overview, telling you something about the history of RML, where we are going, and also take you through exactly what we've done, which we believe is a very new and very innovative product for us as a company. So let's make a start. So what is RML? RML is a company with a very rich history in racing. So we've done lots of products for Nissan, the Z-Yacht, which was a hybrid, which drove the first electric lap of Le Mans, Myra. But in the past few years, we've also seen a transition to a more OEM project revenue stream. So that can be chassis engineering, powertrain engineering, electronics, manufacturing, and all sorts of other capabilities that we have. And a big market we've entered recently has been electrification. And we are currently developing our capabilities and also developing products for our customers. Another big area where we've been concentrating in the past few years has been simulation. Hopefully one of these days simulation will be part of the services that RML offers. And we have been using the simulation capabilities that we have to drive important decisions into our major projects around high performance and racing products. And one of the things we recognized pretty early on was the expertise and the capabilities that ChassisSim offers. And that's why we went with the partnership that we have, and that has been very, very rewarding and productive on the project side. So giving you a bit of an overview of simulation at RML. So it's always been our goal to offer not just world-class engineering in general, but also world-class engineering simulation capabilities, and to get the right answer to your engineering questions, simulation plays more and more of a foundational role. But having said that, the simulation capabilities in the past had not always lived up to the expectations that RML had and has. So that's why for the past 3 years we've been on a journey to completely revamp and develop our simulation capabilities pretty much from the ground up. And that has been driven by a few key requirements. One of them being having fully scalable, accurate, and IP, so intellectual property-based vehicle models. You wanted to have that level of control over the, especially the powertrain models on the hardware and software side. We wanted to have agnostic simulation capabilities from the perspective of the powertrain. So we wanted to be able to model a conventional vehicle with a V8 engine and a manual transmission, let's say, or model a fully hybridized hypercar with multiple electric machines, high voltage battery, and a powerful engine. And also we wanted lap time simulation capabilities, which had very accurate representations of what the chassis, the suspension were doing, and also the circuit itself. And this is where the cooperation with ChassisSim was key for us. Now, we could have gone a separate way. We could have developed our own capabilities in-house, which obviously means a lot of places a lot of demands on time and the expertise required to deliver such capabilities. We did decide in the end to go for a market solution. We did look at multiple available solutions that were widely considered to be class leading in the lap time simulation area, and we found ChassisSim. But our ambition wasn't just to purchase ChassisSim as a standalone license and then use it as a standalone tool separate from our other simulation environments. No, we wanted to actually incorporate the capabilities of ChassisSim and make them work together in a co-simulation with the powertrain models that we've been developing in-house in the MathWorks MATLAB environment. But then the question was, how do we go about achieving it? Now, it turns out that for what we were trying to do, the ChassisSim driver-in-the-loop DLL was exactly the key ingredient we were after. It replicates all of the physics that happen in the front end of ChassisSim. So the big executable where you can run simulations, all of those physics are replicated in the driver-in-the-loop DLL. But since it's a dynamic library, it means that it can be called by other software. So as Danny mentioned, we worked a lot towards cracking the puzzle of how do you integrate the ChassisSim the driver-in-the-loop library into MATLAB, which turns out hadn't been done up until that point. So we had to do a lot of back and forth, a lot of meetings, a lot of emails, a lot of work, a lot of development. At every point in time, Danny has been amazing in his support. I guess that's the main advantage with going with a bit of a more bespoke software, where if you have things to ask changes, new requirements, you don't have to go through a customer relationships department that has no idea how the software works or have no power to actually change how the software works. With ChassisSim, we go straight to Danny. we ask, hey Danny, can you please do this? And he unfailingly always comes back with something that works first try. So that's been amazing. And we managed to integrate the driver in the loop DLL, managed to call it from MATLAB, which I believe is the first. And that has enabled us to achieve co-simulation, true co-simulation between our own in-house powertrain hardware and software models and all the capabilities that ChassisSim comes with in the chassis, suspension, and circuit modeling. So if we look schematically what we were trying to achieve, on the left-hand side you have the ChassisSim area of expertise, if you will. So you have the racing driver model, you have the longitudinal and lateral dynamics model, you have the same longitudinal lateral tire modeling, aerodynamics, suspension modeling, so things like suspension travel over bumps and how the springs behave and how the dampers behave. And then on the right-hand side you have the RML simulation models, where you can have engine models, electric drive unit models, battery, gearbox, driveline, the control strategy. So that enables us to actually optimize powertrain control strategies through software in the loop, which has proved very useful in the past, and also enables us to develop things like battery management systems and develop them in a virtual environment. You don't have physical prototypes working, and also enables us to do a lot of thermal modeling, which is what the case study we will look into a bit later actually looked at. So how we managed to achieve it. So this is a schematic of all of the good bits of code and interactions that have been implemented in the background. I won't go through all of this, but this is a very high-level overview, and rest assured, the actual code behind it is much more complex than this very simplistic overview shows. So with that being said, I think it's worth going through a case study just to show that these capabilities that for us were new were put to good use. And we have been given multiple opportunities to prove these capabilities out, which has been great. I think one of the ones we're particularly proud of is a pretty demanding case study where we had to engineer the complete cooling vehicle cooling system for a hybrid hypercar, which had multiple electric machines, all powered by a liquid-cooled high-voltage battery. So you can imagine the level of complexity that is required to be able to do such a task. Now, previously, and this is from my experience, how I would have done resolve this problem in the past without the co-simulation between the ChassisSim and RML vehicle models, is I would have run ChassisSim to simulate the lap time performance of the car and generate the vehicle speed profile against distance, feed that resulting profile into our powertrain hardware and software models, essentially running it as an open loop where the powertrain models only had to follow the predefined speed coming out of ChassisSim and then generate the component heat duties, use those heat duties in simple 0D, so steady state calculations to estimate the operating temperatures at which each component will stabilize, and then optionally feed back the operating temperatures into the original powertrain simulation to update the heat rejection, because lots of components obviously have temperature-dependent efficiencies which affect the heat generation. So this is how the loop would look, but obviously it's a broken loop because it relies on the user as an interface between ChassisSim, between MATLAB powertrain models, and between whatever was used to do the 0D steady state calculations for the component operating temperatures, which isn't great because in this case, vehicle speed doesn't affect cooling system airflow. Well, it does affect cooling system airflow, which affects cooling system performance, but then that cooling system performance, because it's a broken loop, doesn't go back into the battery temperature, which then affects battery power delivery, which then affects wheel power, which then would affect vehicle speed. So that key ingredient is lacking where you have that causal chain. Now, how we actually solve it, since we have the luxury of the co-simulation between ChassisSim and our models, is we've just run the model, and that was pretty much it. So you have the full causal chain where all of the different effects follow each other. So vehicle speed affects cooling system performance. The cooling system performance then affects the temperature of the battery, which then affects the heat rejection coming out of the battery, and also affects the battery power delivery, which affects the vehicle speed itself. So you go through this loop, which means that your results gain an additional degree of accuracy and representative results. So just to give you an indication, so on the right-hand side you have plots which show the vehicle speed around multiple laps of a certain circuit. On the middle plot, the second plot from the top, you have battery power. The third plot is cell state of charge. The fourth plot shows how the battery cell temperature changes as the simulation is running, and the ones below show the temperatures for the other hybrid components. Now, and we also have the relative lap times, shows how the performance of the car changes from lap to lap due to changes in the temperature of the components, due to the reduction of state of charge in the battery, which limits deployment. So the car becomes slower from lap to lap. So do you want to capture the change in internal resistance in the battery based on cell temperature? You can do that. Do you want to capture the change in battery power deployment based on cell temperature? We can do that. Do you want to capture the change in cell heat rejection based on battery power and temperature? We can do that. And we can also capture the change in vehicle speed due to changing battery power levels, which is great. Because, as I said, for us, having this closed loop causal chain for us leads to more accurate results, and we have proved that in the past in the projects we've worked on, including this. So to summarize, ChassisSim has become a key component of RML simulation capabilities. So the cooperation between us and ChassisSim has been very, very fruitful, and we have achieved an industry-first integration of the ChassisSim driver-in-the-loop DLL into MATLAB, which we consider a big achievement, and that's a unique selling point of RML simulation capabilities. It has opened up a lot of new avenues for us in ways of simulating and optimizing solutions, and also visualizing trade-offs between, let's say, cooling system performance, battery performance, and aerodynamic detriment that goes with additional cooling. We have been able to introduce things like lift and coast optimization for EV race cars. We have the capabilities of automating our battery cell selection and also the sizing of battery for different applications. We've done suspension setup optimization to optimize lap performance, and we have done a lot of design of experiment parameter sweeps And these are new capabilities based on the integration that we've achieved. And in the future, we will see more and more of the high-performance projects that we worked on and we will work on being influenced and guided by the capabilities that we have unlocked. And that is it. Hopefully you found this slide deck interesting. Danny, over to you.
Yes, look, really, I mean, Alex, thank you for that very, very informative presentation. The only thing I will say to wrap things up is that what you've seen in this presentation has primarily been RML's legwork. I mean, we at ChassisSim ultimately provided the tools to make that happen. But I think particularly what's really significant about what Alex has just discussed is that ability to take something like a race-proven, battle-hardened vehicle dynamics package like ChassisSim, and then combine it with the expertise that RML had, and be able to take the ChassisSim driver-in-the-loop DLL, incorporate it as function. I thought was an absolute game changer, and also too in terms of those results you just saw Alex present. I have very little to do with it. I was just the software provider actually providing the tools. Now, sure, Alex said, look, could it do X, Y, and Z? And I said, yeah, sure, no problem. So I ultimately delivered that capability. But that hard work and those results are ultimately due down to the expertise of RML Group, which I think actually speaks volumes to the veracity of both our tools that we could get going very, very quickly. Indeed, once we actually really got into the business end of all this, one of the things that I think I got particularly shocked in, I think, Alex, it might have been 6 or 7 weeks in, where you said, "Hey, look, we need to have a meeting." And then we had a meeting, and you showed me the first cut of this, and I was like, "Wow, I didn't expect it to happen that fast." And so I think I think those bits and pieces really speak not only to the veracity and the effectiveness of both our tools and both our expertise, but also too that what RML has done here is something very unique, very, very special. And I think that to anyone who's tuning into this, if you've got a really big project coming down the way, I mean, look, you've got to be giving RML Group a call. It's as simple as that. Yeah, I think that's probably my 2 cents worth on this.
Yes, it's. I think you're a bit underplaying your role in getting this over the line. But yeah, I agree. It's been a great journey. It's been a lot of learning happening in the background, especially doing something that hadn't been done up until that point. So it's not like you can Google search the solution to achieving what we've achieved. So it was a good learning curve, and we're here, and the results speak for themselves, and it's been greatly appreciated, especially by RML management. They really believe it is a unique selling point for our capabilities, and I say ChassisSim is here to stay at RML.